we mean by an equation? A mathematical statement which has equality sign in it is called an equation. For example, 8 equals 2 plus 6, minus 6 equals 5 minus 11, x plus 2 equals 5, y minus x equals 8, x squared minus y equals minus 2. These are all equations. Equations consisting of variables or unknowns such as x, y, z, m, n, etc. are called algebraic equations. In the above example, 8 equals 2 plus 6, then minus 6 equals 5 minus 11. These are numerical equations. Whereas x plus 2 equals 5, y minus x equals 8, x squared minus y equals minus 2. These are algebraic equations. Our topic of interest is, of course, algebraic equations. Consider this equation. 2x minus 3y equals 5y minus 7x. This has three parts. Equality sign. Here is the equality sign. Then expression on the left hand side of equality sign, abbreviated as LHS. This is the LHS. Expression on the right hand side, abbreviated as RHS. This is RHS. An equation can be compared to a scale into which weights are placed. When equal quantities of something, jaggery for example, are placed into the two pans, the two weights cause the scale to be in balance and the weights are said to be equal. If a quantity of jaggery is removed from one pan of the scale, an equal amount of jaggery must be removed from the other pan to keep the scale in balance. Similar is the case while adding. This analogy leads us to the properties of an equation. Properties of an equation. If same number is added to or subtracted from both the sides of an equation, the equation remains true or balanced. If A equals B, then A plus C equals B plus C, and also A minus C equals B minus C. If both the sides of an equation are multiplied by the same number, then the equation remains true or balanced. If A equals B, then A into C equals B into C. The third property is, if both the sides of an equation are divided by the same non-zero number, the equation remains true or balanced. Why non-zero number? Because we cannot divide by 0. Dividing by 0 is prohibited in mathematics. If A equals B, then A divided by C equals B divided by C, C not equal to 0. Now, what do we mean by linear equations? In an equation, if the highest power of the variable or variables is 1, then the equation is called a linear equation. Consider the following equations: x squared minus x equals 7, y minus x equals 8, 3x minus 4y plus 5z equals 12, 5m cubed minus 2m squared equals 15, 3y minus 4 equals 3 whole into 2y plus 5, 3t plus 5 whole multiplied by 2t minus 3 equals 7, 3x minus 4 equals 10. Among these, which are the linear equations? What about the first one? Here, the highest power of the variable is 2. Therefore, this is not a linear equation. What about the second one? Here, the highest power is 1. Therefore, it is a linear equation. Here, there are 3 variables x, y and z. The highest power is 1. Therefore, this is also a linear equation. What about this one? Here, the highest power is 3. Therefore, this is not a linear equation. What about this example? Here, the variable is y. The highest power is 1. Here, the variable is t. Highest power is 1. Here, the variable is x. The highest power is 1. Therefore, all these are linear equations. Out of these, which are having only one variable, consider the first one. Here, there are 2 variables, and in this, there are 3 variables. What about this one? There is only one variable. Here also, there is only one variable t. Here again, the variable, the lone variable is x. Solution of linear equations in one variable. Look at this linear equation in variable x. X plus 2 equals 7. For what value of x the equation is true? 2 is added to a number to get 7. Of course, the value of x is 5. It's quite simple. X equals 5 is called the solution of the given equation. Solution of a linear equation in one variable is that value of the variable for which the equation is true or balanced. We can also say the equation is satisfied. Is there any value other than 5 which satisfies the given equation? No, there is only one value. Solving the equation means finding the solution. Here is one more example. 5x minus 6 equals 2x minus 4. Can you guess the value of x which satisfies the equation? It's not easy. In fact, it is quite hard. Based on the properties of equations, there is a procedure to solve such equations. Let us understand this procedure with the help of some examples. Here is example 1. Solve for x. It's a very simple equation. X plus 3 equals 7. We can guess the value of x here. X is 4. But let us find the value of x using the properties of equation. This can also be called method of balancing the equation or method of inverse operations. Let us write down the equation. X plus 3 equals 7. On the left hand side, we have x plus 3. We need only x on the left hand side. We should get rid of plus 3. How do we do that? We subtract 3 from both the sides. Note that subtraction is the inverse operation of addition. Now plus 3 and minus 3, their algebraic sum is 0. Note the equation here. We get x equals 7 minus 3. This is as good as bringing plus 3 from the left hand side to the right hand side by changing its sign. X equals 4. Now there is one more method, a shortcut. X plus 3 equals 7. Let us bring plus 3 to the right hand side and change its sign. Compare these two. X equals 7 minus 3 in the first method. In the second method again, we got x equals 7 minus 3. They are one and the same. But in the second method, steps are few and it is easier. This bringing of plus 3 to the right hand side and changing its sign is called transposing. While transposing, addition becomes subtraction, subtraction becomes addition, multiplication changes into division, division transforms into multiplication. X equals 4. How do we ascertain that our answer is correct? Let us verify. Let us start from the left hand side. Left hand side is equal to x plus 3. Substitute the value of x. X is 4 here. 4 plus 3 equals 7. That's what we have on the right hand side of the equation. This is equal to right hand side. Let us take one more example. Example 2. Solve for y. Y minus 2 equals 4. Let us solve this equation using both the methods. Balancing the equation or method of inverse operations. Y minus 2 equals 4. We need to get rid of minus 2 on the left hand side. To do that, we add plus 2, we add 2 to both the sides. Minus 2 and plus 2, they get cancelled. Y equals 6. Let us solve the same equation using the second method by transposing the terms. Let us transpose minus 2 to the right hand side. It becomes positive, plus 2. Compare these two. These two are one and the same. By cancelling minus 2 and plus 2, we get y equals 4 plus 2 in the first method. In the second method too, we got the same result. Y equals 4 plus 2. Therefore, these methods are one and the same. Y equals 6. Let us verify our answer. Left hand side is y minus 2. Substitute the value of y here. Y is 6. 6 minus 2 equals 4. This is equal to the right hand side. Before moving further, if you have not subscribed to my channel, please do it now. Press the bell icon to get early access to my videos. Also like and share. Let us go to the next example, example 3. Solve for m. 2 plus m equals minus 5. Let us solve this using the first method. 2 plus m equals minus 5. We need to get rid of 2 from the left hand side. To do that, we subtract 2 from both the sides. Note here that the inverse operation of addition is subtraction. Now plus 2 minus 2, their algebraic sum is 0. What do we get? M equals minus 5 minus 2. This is as good as transferring 2 from the left hand side to the right hand side by changing its sign. M equals minus 7. Now let us solve the same equation using the method of transposing. Let us transpose 2 to the right hand side. When we say 2, it is plus 2. It changes its sign. Compare these two. These two are one and the same. M equals minus 7. Let us verify our answer. We shall start from the left hand side. 2 plus m equals 2 plus m is minus 7 here. 2 minus 7 is minus 5. This is what we have on the right hand side of the given equation. Now example 4. Solve for x. 3x equals 21. Let us solve using both the methods. First method. 3x equals 21. When we say 3x, it is 3 into x. To get rid of 3, we divide both the sides by 3. Inverse operation of multiplication is division. Like this. Divide by 3. 3 ones are 3 ones are. 3 ones are 3 sevens. X equals 7. Now let us go to the second method. 3x equals 21. 3 into x equals 21. Let us bring 3 to the right hand side. Let us transpose 3 to the right hand side. This divides 21. 3 divides 21. 3 ones are 3 sevens are. X equals 7. Let us verify. Start from LHS. 3x equals 3 into 7 equals 21, which is equal to the right hand side of the given equation. Example 5. Solve for y. Y over 6 equals 5. First method. Y over 6 equals 5. 6 divides y. Inverse operation of 6 is multiplication. We multiply both the sides by 6. 6 ones are 6 ones are. Y equals 30. Second method, method of transposing. Y divided by 6 equals 5. We transpose 6 to the right hand side. Then it multiplies 5. Y equals 5 into 6. Y equals 30. Let us verify the answer quickly. Start from the left hand side. Y over 6 equals y is 30. 5 are 6 ones are equals 5 equals the right hand side. Example 6. Solve for n. 3 minus n equals minus 5. Note here that the variable n has negative sign. Let us solve this using the first method. 3 minus n equals minus 5. To get rid of 3 from the left hand side, we subtract 3 from both the sides. 3 minus 3 is 0. Minus n equals minus 8. We need to make n positive. To do that, we multiply both the sides by minus 1. Plus n equals plus 8, that is n equals 8. Or you can solve the equation in this way also. 3 minus n equals minus 5. We get rid of minus n from the left hand side. To do that, we add n to both the sides. Minus n plus n get cancelled. Note that n has become positive, but it is on the right hand side. Now we need to get rid of minus 5 from the right hand side. 3 equals minus 5 plus n. Add 5 to both the sides like this to get rid of minus 5. 3 plus 5 is 8. Minus 5 plus 5 get cancelled. 8 equals n. Let us interchange the sides. Let us swap the sides. n equals 8. Method of transposing. 3 minus n equals minus 5. Let us transpose 3 to the right hand side. It becomes negative. Minus n equals minus 8. Multiply both the sides by minus 1 to make n positive. Plus n equals plus 8. n equals 8. Or 3 minus n equals minus 5. Let us transpose minus n to the right hand side and minus 5 to the left hand side. They change their signs like this. 3 plus 5 is 8 equals n. Let us interchange the sides. n equals 8. Let us verify the answer quickly. Start from LHS. 3 minus n equals 3 minus 8. 3 minus 8 is minus 5, which is the right hand side of the given equation. From here onwards, we shall use only the method of transposing or the shortcut method. Example 7. Solve for x. 3x plus 2 equals x minus 4. This example is different from the previous examples. Here we have a variable on both the sides. How do we tackle this? Let us see. 3x plus 2 equals x minus 4. Now we group the like terms on the same side. 3x and x are the like terms. 2 and minus 4, they are also the like terms. Let us bring x means plus 1x to the left hand side and plus 2 to the right hand side. Then they change their signs. 3x minus 1x equals 2x. Minus 2 minus 4 is minus 6. Now bring 2 to the right hand side. It divides minus 6. 2 ones are 2 threes are. x equals minus 3. Let us verify our answer. LHS equals 3x plus 2. Note here that you cannot start from LHS and arrive at RHS in such examples. What we do here is we evaluate LHS and RHS separately and then show that they are equal. Now 3 into x is minus 3. 3 into minus 3 is minus 9 plus 2 equals minus 7. Let us evaluate RHS. X minus 4. X is minus 3. Minus 3 minus 4 is equal to minus 7. Their algebraic sum is minus 7. So LHS equals RHS. Example 8. Solve for x. 5x plus 5 equals 8x minus 8. Let us write down the equation and let us collect the like terms on the same side. Bring 8x to the left hand side and 5 to the right hand side. They change their signs. 5x minus 8x is minus 3x equals minus 5 minus 8 equals minus 13. To make 3x positive, let us multiply both the sides by minus 1. We get plus 3x equals plus 13. 3 into x equals 13. Bring 3 to the right hand side. Transpose 3 to the right hand side. It divides 13. Therefore, x equals 13 over 3. Or 5x plus 5 equals 8x minus 8. Instead of bringing 8x to the left hand side, we shall collect the terms containing variables on the right hand side and numbers on the left hand side, like this. 13 equals 3x. Advantage of this method is we don't get negative 3x here. Swap the sides. Interchange the sides. Now 3 into x equals 13. X equals 13 over 3. Let us verify. 5 into 13 over 3 plus 5. Let us simplify this like this. We get 80 over 3. We need to evaluate LHS and RHS separately here because we have variable on both the sides. RHS equals 8x minus 8. Substitute the values and simplify. We get again 80 over 3. Therefore, LHS equals RHS. Example 9. Solve for t. 2t over 3 equals 5 over 2. In this example, we have two fractions on both the sides. Such problems can be solved by cross multiplying like this. Bring 2 to the left hand side and 3 to the right hand side. 2t into 2 equals 5 into 3. 4t equals 15. 4 into t equals 15. T equals 15 over 4. Let us verify our answer quickly. 2t over 3, that is 2 into 15 over 4 whole divided by 4. 2 over 1 into 15 over 4, 2 ones are, 2 twos are, we get 15 over 2 divided by 3 over 1. You know how to divide fractions. 15 over 2 into multiplicative inverse of 3 over 1 is 1 over 3. 3 ones are 3 fives are 5 over 2 equals RHS. Example 10. Solve for x. X over 3 plus 5 over 2 equals minus 3 over 2. Let us write down the equation. Now bring plus 5 over 2 to the right hand side. It becomes negative. On the right hand side, we have two fractions and their denominators are equal. So we can write the numerators over the common denominator like this. Minus 3 minus 5. Then we get x over 3 equals minus 8 over 2. 4s are 2 1s are. X over 3 equals minus 4. Bring 3 to the right hand side, it multiplies minus 4. X equals minus 12. Or this problem can be tackled in another way like this. X over 3 plus 5 over 2 equals minus 3 over 2. If we can get rid of the denominators, then solving this equation would be easier. To get rid of the denominators, what we do is we multiply the entire equation by the LCM of the denominators. LCM of 3 and 2 is 6. Since 3 and 2 don't have any common factor, their product is itself the LCM. Let us multiply each term by 6 into 6 into 6 into 6. 3 ones are 3 twos are, 2 ones are 2 threes are, 2 ones are 2 threes are. What do we get? 2x plus 15 equals minus 9. Now bring or transpose plus 15 to the right hand side. It becomes negative. 2x equals minus 24. 2 into x equals minus 24. X equals minus 24 divided by 2. Transpose 2 to the right hand side. It divides minus 24. 2 ones are 2 12s are. X equals minus 12. Let us verify the answer quickly. X over 3 plus 5 over 2. In place of x, substitute minus 12. 3 ones are 3 fours are. Minus 4 plus 5 over 2. Minus 4 divided by 1 plus 5 divided by 2. The common denominator here is 2. Then we get minus 8 over 2 plus 5 over 2. 2 is the common denominator. Let us write down the numerators over the common denominator like this. Minus 8 plus 5. This is equal to minus 3 over 2. This is minus divided by plus is minus. Therefore, minus 3 over 2. This is equal to RHS. Example 11. Solve for x. 15 over 4 minus 7x equals 9. Let me follow the second method here. Multiply the entire equation by 4. 4 is the only denominator here. Into 4, into 4, into 4. 4 and 4 get cancelled. 15 minus 28x equals 36. Now bring minus 28x to the right hand side and 36 to the left hand side. They change their signs. 15 minus 36 equals minus 21 equals 28x. Interchange the sides. Bring 28. Transpose 28 to the right hand side, it divides minus 21. 7 fours are 7 threes are. X equals minus 3 over 4. Verification. Let us do it quickly. Here we need not evaluate LHS and RHS separately because we have 9 in the RHS. It is a number. Substitute the value of X. Now 15 over 4, minus into minus is plus, 7 over 1 into 3 over 4 equals 15 over 4 plus 21 over 4. 4 is the common denominator. Write down the numerators over the common denominator. 36 over 4. 4 ones are, 4 nines are. This is equal to 9, which is the right hand side of the given equation. Example 12. Solve for x. 5x plus 7 by 2 equals 3 over 2x minus 14. Here again we have variable on both the sides. How do we solve this? The easiest method is, here we have the denominator 2. Multiply the entire equation by 2. Each term by 2. Like this. 2 and 2 get cancelled. Here also 2 and 2 get cancelled. 10x plus 7 equals 3x minus 28. Collect the like terms on the same sides. 10x minus 3x equals minus 7 minus 28. 7x equals minus 35. X equals minus 35 over 7. We have transposed 7 to the right hand side. 7 ones are, 7 fives are. X equals minus 5. Please verify the answer yourself. Here we need to evaluate LHS and RHS separately and then show that LHS equals RHS. From the next example onwards, I will do away with the verification step. It is left as an exercise to the enthusiasts. Example 13. Solve for x. 8x plus 4 equals 3 whole multiplied by x minus 1 plus 7. 8x plus 4 equals 3 into x minus 1 plus 7. Let us open the brackets. 3 into x, 3x, minus 3 into 1, 3, plus 7. 8x plus 4 equals 3x, minus 3 plus 7. They are the like terms and they are on the same side. Let us find their sum, their algebraic sum. Minus 3 plus 7 is plus 4. Now collect the like terms on the same side. 8x minus 3x equals minus 4 plus 4. 5x equals 0. Minus 4 plus 4 get cancelled. X equals 0 divided by 5. X equals 0. Or 8x plus 4 equals 3 into x minus 1 plus 7. 8x plus 4 equals 3 into x minus 3 into 1, that is 3, plus 7. 8x plus 4 equals 3x plus 4. Look here, we have plus 4 on both the sides. In such cases, we can directly cancel like this. Plus 4 and plus 4 get cancelled. We get 8x equals 3x, bring 3x to the left hand side. 8x minus 3x equals 0, 5x equals 0, x equals 0 divided by 5, x equals 0. Example 14. Solve for x. X equals 4/5 whole multiplied by x plus 10. X equals 4 divided by 5 multiplied by x plus 10. Or this can be written as x plus 10 divided by 1. X equals 4 into x plus 10 divided by 5. Bring 5 to the left hand side. Transpose 5 to the left hand side. It multiplies x. 5x equals 4 into x, open the brackets, 4x plus 4 into 10, 40. Bring 4x to the left hand side. 5x minus 4x equals x, x equals 40. Example 15. 2x over 3 plus 1 equals 7x over 15 plus 3. Here again we have got denominators. For 3 and 15, 15 is the LCM because 3 goes into 15 exactly. 3 5s are 15. Therefore, in such cases, bigger number is the LCM. Multiply the entire equation by 15. Into 15, into 15, into 15, again 3 into 15. 3 ones are 3 5s are 15 ones are 15 ones are. What remains? 2x into 5 is 10x plus 15 equals 7x plus 45. Collect the like terms on the same side. 10x minus 7x equals minus 15 plus 45. 3x equals 30, x equals 30 over 3. 3 ones are 3 tens are. X equals 10. Example 16. Solve for y. 2y plus 5 over 3 equals 26 over 3 minus y. Here again, multiply the entire equation by 3 because 3 is the only denominator here. Into 3, multiply each and every term by 3. 3 ones are 3 ones are, 3 ones are 3 ones are. What remains? 6y plus 5 equals 26 minus 3y. Collect the like terms on the same side. 6y minus plus 3y equals 26 minus 5. 9y equals 21. Y equals transpose 9 to the right hand side. It divides 21. 3 is the common factor here. 3 3s are 3 7s are. Y equals 7 over 3. Last example, example 17. Solve for m. 3m equals 5m minus 8 over 5. Here, multiply the entire equation by 5. 3m into 5, 5m into 5 minus 8 over 5 into 5. 5 ones are 5 ones are. 15m equals 25m minus 8. Now transpose 15m to the right hand side minus 8 to the left hand side. 8 equals 10m. M equals transpose 10 to the left hand side. 8 over 10. 2 5s are 2 4s are. 4 divided by 5 equals m. Now interchange the sides, swap the sides. M equals 4 over 5. That's it for now. We shall discuss some applications of linear equations in one variable in the next session. See you then.